in an interference experiment, in an interference experiment, okay, the ratio of the amplitudes, they gave it as A1 by A2 is equal to 1 by 3. Okay, right? Okay. We need to find ratio of maximum and minimum intensities. Maximum and minimum intensities. Okay, fine. Of the fringes will be. Now, you can see that you can write as A1 by A2 is equal to 1 by 3. 1 by 3, right? Okay. Maximum intensity. Maximum intensity to the minimum intensity. We can write it as under root I1 plus under root I2 whole square upon under root I1 minus under root I2 whole square. Okay. Actually, this is the formula. Or else I can write as maximum amplitude square by minimum amplitude square. That is A1 plus A2 whole square upon A1 minus A2 whole square. Right? So by using component or dividend method, okay, we can get as A1 plus A2 by A1 minus A2. We'll get as 4 by, okay, 4 by 2. Actually, we'll get 1 minus 4, we'll get 2. Take modulus. Okay, so A1 plus A2 by A1 minus A2 whole square. Okay, A1 plus A2 by A1 minus A2 whole square. We'll get it as, this is 2 by 1. So
Yes, sir.
I max by I min. Maximum intensity to the minimum intensity. Maximum intensity to the minimum intensity. It is given as, 4 by 1.
Yes, sir.
4 is to 1. That is option C. Okay, right on.
Completed.
Completed. Okay. Next. See the next question. That is, uh, the diagram shows a, the diagram shows a Young's double slit experiment setup. Okay. It is observed that, okay, it is observed that when a thin transparent sheet, when a thin transparent sheet of thickness T and refractive index mu is put in front of one of the slits, is put in front of one of the slits. Okay, the central maximum, the central maximum gets shifted by a distance equal to n times fringe width. Okay, so here the central fringe width is shifted by n times the fringe width. If the wavelength of light used is t lambda, we need to find t. We need to find t. We know that suppose this is the source. Here it is the double slit, right? They are saying that it is observed that when a thin transparent sheet of thickness t and refractive index mu is put in front of one of the slits, okay, one of the slits. Suppose if I keep here, okay, okay, from this light rays will pass, okay. So in this transparent thin sheet, it is having a refractive index mu and it is having a thickness t. So the path difference in this transparent sheet will be mu t, will be mu t.
Yes, sir.
Okay, since it is moving from, okay, that is the total distance traveled. It is t minus mu t, apparent shift. Okay, fine. Okay, now the fringe width yn I can write as capital D by small d times delta. Okay, that is nothing but capital D by small d times mu minus 1 into t. Okay, fine. Okay, okay. Without this transparent sheet, we know that yn is equal to capital D by small d times delta. For bright fringes, it is yn is equal to capital D by small d times n lambda. Okay,
Yes, sir.
they gave that it is the central fringe is shifted by is shifted by n times the fringe width, right? Okay.
Yes, sir.
So I will call this as yn dash, this as yn. Okay. So yn dash is equal to, okay, yn dash is equal to yn, that is n times the fringe width, n times capital D by small d into lambda is equal to mu minus 1 into capital D by small d into t. Upon calculation, we'll get as t is equal to n lambda by mu minus 1,
Yes, sir.
n lambda by mu minus 1. Okay, right.
Yes, sir.
Right.
Completed.
Completed. Okay, next one. See the next question. That is diameter of the objective lens. Diameter of the objective lens of a telescope is, and for the wavelength. See, that means resolving power of telescope and a limit of resolution. In some textbooks, they will give wave optics. In some textbooks, they will give the wave optics. Okay. Actually, it must be there in the ray optics only. They gave that here it is diameter of the objective lens. It is given as 250 centimeter. Wavelength as 600 nanometers. That is nothing but 600 times 10 power minus 9 meter. They are asking what is the limit of resolution. What is the limit of resolution? That is theta r. Okay. Okay. Since we know that we are having the formula that limit of resolution theta r equal to 1.22 lambda by capital D. Lambda by capital D. They gave all the values lambda and capital D. Okay. Convert this diameter into centimeters. That is nothing but 1.22 times 600 into 10 power minus 9. I'll write as 6 into 10 power minus 7 upon 250 into 10 power minus 2. Okay, fine. Okay, 1.226 7.32 7.32 into 10 power minus 6 by 25 divided by 25. Okay. Na? So what I will do, multiply and divide by 4. So that 7.32 into 4, 29.28. 29.28 into 10 power minus 6. In the denominator will be 100. That is 10 square. That is 29.28 into how much will get 10 power minus 8. That
Yes,
is
sir.
approximately, we can write 3 into 10 power minus 7 radian.
Yes, sir.
3 times 10 power 7 radian. Okay, na? Right.
Yes. Right.
Completed. Next. Hmm. Next question. In a Young's double slit experiment, the ratio of slit widths is 4:1. The ratio of the maxima to the minima close to the central fringe on the screen will be. Okay. Okay. They are asking to maximum ratio of maximum intensity to the minimum intensity, right? And they give the ratio of slit width. Ratio of slit width. Okay. Ratio of slit width means what?
Width of the
That
slit.
uh, width of the slit only. Okay. And now you can see it depends upon the width of the slit. We'll have the amplitude, or amplitude is directly proportional to slit width.
Yes, sir.
Okay. Na? Fine. Okay. So they gave that. Let us consider amplitudes are A1 and A2. A1 and A2. Okay. Okay, fine. So A1 and A2. A1 by A2 whole square is equal to 4 by 1. 4 by 1. So that is intensity I1 by I2 is equal to 4 by 1, because intensity equal to some constant into A square. So I max by I min. Okay, na? Fine. That is under root I1 plus under root I2 by under root I1 minus under root I2. Okay, fine. Mhm. Whole square, right? So root I1, I can write as 2 root k plus root k by 2 root k minus root k whole square. So that ratio will be 9:1. That is option C. Or else here only A1 by A2 whole square equal to 4 now. You can use component or dividend.
Yes, sir.
Okay,
Completed, sir.
completed. Okay, fine. Hmm. See the next question. Okay, see the next question. That is in double slit experiment. Okay, in double slit experiment, when a thin film of thickness T having a refractive index mu, okay, of refractive index mu and thickness T is introduced in front of one of the slits. The maximum at the center of fringe pattern shifts by one of the fringe width by one of the fringe width. Then the value of T is okay. Okay, I think similar to the one of the question we discussed now. I think
Sir.
second question or first, not first one. I think second question. Okay. Suppose
Same,
we
sir.
are having
Instead of n, we should write 1.
instead of there they gave n, here it is one. Okay, here it
So
is.
lambda by
So
mu minus 1.
delta equal to mu minus one into t, right? So yn
Yes, sir.
dash I will consider capital D by small d into delta. Okay, that is they gave it as one. So capital D by small d. Okay, that is equal to capital D by small d into mu minus 1 into t. So t equal to lambda by mu minus 1. That is option C. Similar application.
Yes, sir.
Mm.
Completed.
Completed.
Yes.
Okay, fine. Now see the next question. See the next question. We are having that mm, a system of three polarizers, P1, P2, P3 is set up such that the path axis of P3 is crossed with respect to that of P1. The path axis of P2 is inclined at 60 degrees to the path axis of P3. When a beam of unpolarized light of intensity I0 is incident on P1, the intensity of light transmitted by the three polarizers is I. Then the ratio I0 by I. We need to find I0 by I. So, firstly, I will consider a polarizer P1. Okay. The path axis of P3 is crossed with respect to that of P1. Okay. Fine. Okay. Suppose let us consider this is the path axis. Okay. Okay. The path axis of P2 is inclined at an angle, and here it is P3. Okay. With respect to P3, the path axis of P2 is at an angle 60 degrees. Okay. Okay. Now you can see this one. Okay. Let us consider this value they give as 60 degrees. This is P2 and this one it is P3. Okay. So here it is 30. Okay. And here the theta it is 60. Okay. Fine. So I can say that it is initially we are having unpolarized light. According to Malus law, for unpolarized light, it is I1 is equal to I0 by 2 cos square theta, right? Unpolarized light is having an intensity. They gave I0. See this one. So I1 is equal to theta will be in order to have the unpolarized light, I1 to be maximum, theta will be 0. Theta will be 0. I1 is equal to I0 by 2. Okay, na? Fine.
Yes, sir.
Okay, fine. Call it as equation 1. Now, on the second polarizer, emitted light, I2 it is the intensity of this one here, emitted light. Okay, that is nothing but I1 times cos square 30,
Yes, sir.
I1 times cos square 30. Okay, that is nothing but I1 means I naught by 2, cos square 30, I can write as 3 by 4. So I2 is equal to 3 I naught by 8, equation 2. And similarly, equation 3. When this light passes through the third polarizer, P3, then we can write as I2 cos square 60. Okay, that is
Yes,
3 I naught by 8 times 1 by 4. That is nothing but 3 I naught by 32. Okay, they gave this value I3 as I. So I by I naught is equal to 3 by 32. They are asking to find the ratio I naught by I. I naught by I means
yes, sir.
32 by 3,
Yes,
10.67, right?
yes, sir.
That is option C, most important
Yes, sir.
question. And the same question, it is there in your NCRT or Telugu Academy textbook. Same question. There is no change in value.
Yes, sir.
Okay, na? Right on.
Completed.
Completed.
Yes, sir.
Next. The two coherent sources, okay, produce waves of different intensity which interfere. After interference, the ratio of maximum intensity to the minimum intensity is 16. Okay, that means they gave that it is maximum intensity to the minimum intensity. They gave us 16. Okay, na? Fine. Okay, fine. Now you can say we need to find the intensities of the waves in the ratio. I1 by I2, I need to find it. Okay, I max means I can write root I1 plus root I2 by
Yes, sir.
root I2 whole square. Okay, so root I1 plus root I2 by under root I1 minus under root I2 equal to 4 by 1. So root I1 plus root I2 is equal to 4 root I1 minus 4 root I2. That is nothing but 5 root I2 equal to 3 under root I1. Okay.
Yes, sir.
So root I1 by root I2 is equal to 5 by 3.
Yes, sir.
Okay. So I1 by I2 I can write as 25 by 9. Okay. Now
Yes, sir.
that is option C.
Yes, sir.
Okay, right on.
Completed.
Completed. Okay. Today, if possible, will you be free in afternoon?
Afternoon, sir.
Uh,
అంటే ఏ టైంకి సార్?
2 o'clock కానీ 2:30 కానీ
ఎంతసేపు సార్? ఎంతసేపు ఉంటుంది క్లాస్?
ఒక 1.5 hour.
1:30కి పాసిబుల్ సార్?
1:30కా? అంటే ఈ సెషన్ 1 దాకా అనుకున్నా. 1 to 2 లంచ్ కని పెట్టుకున్నా. ఏమైనా ఎగ్జామ్ ఉందా?
అవును సార్.
ఓకే, నో ప్రాబ్లం. అంటే ఏం లేదు, నేను ఇవాళ యూట్యూబ్ లైవ్ ప్రోగ్రామ్ చేస్తున్నా. ఒకటి గ్రాండ్ టెస్ట్, ఒక పేపర్ ఎక్స్ప్లెనేషన్ చేద్దాం.
ఎస్ సార్.
రోజుకి ఇప్పటి నుంచి ఒక్కొక్క పేపర్ చేసుకుంటూ వెళ్తుంటే ఏమవుతుందంటే,
ఎస్ సార్.
అంటే కొంచెం స్ట్రీమ్ లైన్ అవుతాం కదా, ఏ చాప్టర్స్ ఇది ఉంది లేకపోతే ఏది లేదని తెలుస్తూ ఉంటుంది.
అవును సార్.
అందుకని మధ్యాహ్నం అంటే వేరే మా స్టూడెంట్స్ అడిగారు, సరే చేస్తాను అని.
యూట్యూబ్లో ఉంటుందా సార్ ఆ వీడియో?
యూట్యూబ్లో ఉంటుంది, వీడియో ఉంటుంది. అది
అయితే
వీడియో
తర్వాత
నీకు
చూస్తా.
అదే నీకు కుదరకపోతే అప్పుడు తర్వాతైనా చూడొచ్చు, నో ప్రాబ్లం.
ఓకే సార్.
యూట్యూబ్లోనే ఉంటుంది.
ఓకే సార్.
ఓకే, కంప్లీటెడ్నా?
Yes, sir.
25/9 completed. Yes, fine. See the next question. See the next question. That is, we are having a consider a tank. Okay, consider a tank made of with glass. Okay.
Yes.
I think this question it is from ray optics. No? Okay, fine. Consider a tank made of glass of refractive index 1.5, which is with a thick bottom. It is filled with a refractive index mu. A student finds that irrespective of what the incident angle, okay, incident angle is for a beam of light entering the liquid, the light reflected from the liquid glass interface is never completely polarized. Okay. The minimum value of mu. The minimum value of mu. That means here you can see this question is consisting of both ray optics and wave optics.
Yes, sir.
Okay. They are saying they are saying that whatever be the angle of incidence, okay, the light ray is entering into the liquid, the light reflected from the liquid glass interface, okay, is never completely polarized. Okay, is never completely polarized. That means the critical angle must be greater than, okay, angle of polarization.
Yes, sir.
Then only it will happen. Okay, then only
Yes, sir.
at here interface, if the angle of incidence equal critical angle, then only light ray will be reflected back. Then only this.
Yes, sir.
Okay, this is the condition for the polarized. Okay, they says that never it will be polarized. Okay, this is for
Yes, sir.
completely polarized. Completely polarized. This is never completely polarized.
Yes, sir.
Never completely polarized. That means that it is critical angle must be less than the angle of polarization. or Brewster's angle. So I can say
Yes,
that here it is sine IC. You can consider sine. Okay, fine.
yes, sir.
Okay. Now I can say that it is from the critical angle concept. We know that mu is equal to 1 by sine IC. Instead of sine IC, I can write as 1 by mu. Okay. I want to find sine IP. Sine IP. Okay. That is, you can see by using the Brewster's law, by using the Brewster's law, you can see here we are having that. Okay. We need to find tan. That is mu into sine IP is equal to 1 into sine R. Okay.
Yes, sir.
Okay. Already here we are having the glass. This one it is mu G. Okay. So since IP plus R according to Brewster's law, IP plus R is equal to 90. So mu times sine IP is equal to 1.5 times sine of 90 minus IP. Okay. Okay, fine. So mu times sine IP equal to 1.5 times cos IP. So tan IP is equal to 1.5 by mu.
Yes, sir.
Okay. Okay. From this, that is put the triangle. This is 1.5. This is mu. And here it is IP. So hypotenuse means 1.5 whole square plus mu square. We are having the condition that sine IC is less than sine IP. Since
Yes,
sine IC is less than sine IP, that is 1 by mu is less than sine IP means opposite side 1.5 by under root 1.5 whole square means 2.25 plus mu square. So under root 2.25 plus mu square is less than 1.5 mu. Squaring on both sides
yes, sir.
will get as 2.25 plus mu square is less than 2.25 mu square. So 2.25
Yes, sir.
is less than 1.25 mu square. So 2.25 by 1.25 is less than mu square. So mu square is greater mu square is greater than 225 by 125. 25
Yes,
times
sir.
are 25 5 are. So mu must be greater than 3 by root 5. 1 minute. Mu must be greater than 3 by root 5. Okay.
Yes, sir.
First write down this one.
Completed.
Mm, Completed.
Yes.
Yes.
Yes, sir.
Okay, na?
Completed.
Next one. In a Young's double slit experiment, okay, the slits are placed 0.32 millimeter apart. Light of wavelength lambda is 500 nanometer is incident on the slits. The total number of bright fringes that are observed in an angular range. Okay, theta is having an angular range. Okay, first slits are apart, separated, okay, by distance. That is, I can write it as small d is equal to, okay, small d is equal to 0.032, 0.32 millimeter, 0.32 millimeter. Afterwards, I'll convert it. Okay, and then lambda wavelength they give it as 500 nanometer, 500
Yes, sir.
nanometer. Okay, and they gave the angular width, angular range. It is from minus 30 degrees to plus 30 degrees, plus 30 degrees.
Yes,
Okay,
sir.
fine. We need to find number of bright fringes in this one. Okay, fine. For bright fringe, for bright fringe, okay, I can write it as yn is equal to capital D by small d times n lambda. Okay, okay. Now
Yes,
see,
sir.
here we'll have the source, we are having the slit, and then screen. This is the undeviated ray. Okay, from here, the light ray will get deviated. This is my theta.
Yes, sir.
So this is my yn, and this is capital D. So I can write, since it is a right angle triangle, tan theta equal to yn by capital D. Okay, fine. Okay, fine. Now, instead of tan theta, okay, at for low angles, tan theta is approximately equal to sin theta. When theta is small, tan theta is approximately equal to sin theta, right?
Yes, sir.
Okay, now. Okay, fine.
Yes, sir.
Now you can see that is I can write as sin theta equal to yn by capital D. So yn by capital D is equal to n lambda by small d. That is nothing but sin theta equal to n lambda by d. That is d sin theta is equal to n lambda. Can I write? Okay.
Yes, sir.
Okay. For dark fringes, for dark fringes, we can write as d sin theta must be equal to 2n minus 1 to lambda by 2. This is for bright fringes.
Yes, sir.
Okay. And they asked to find for the bright fringes only. Number of bright fringes. So n
Yes,
is
sir.
equal to d sin theta by lambda. D sin theta by
Yes, sir.
lambda. Theta is 30 degrees. Small d is
Yes, sir.
0.32 millimeter. 0.32 into 10 power minus 3 into 1 by 2 by wavelength. It is 500 into 10 power minus 9.
Yes, sir.
Okay. So n is equal to 0.32 into 10 power minus 3 by 2 into 500 into 10 power minus 9. That is numerator I will write as 32 into 10 power minus 5. Denominator 2 into 500 means 1000. 1000 into 10 power
Yes, sir.
minus 9 means 10 power minus 6. Right? So
320.
that is n is equal to 320. So
Yes, sir.
total number of fringes will be. Now you can see the YDSC pattern with respect to center. With respect to the center, this is the central fringe. Above, how many number of bright fringes are there? Below also, same number of bright fringes will be there,
Yes,
right?
sir.
In the above, okay, that means here we are having 320. So down also 320,
Yes, sir.
and central fringe is a bright fringe, another one. So that I
Yes,
am
sir.
writing it as small n above. This is for above the central fringe. Small n below the central fringe. And this is for plus 1 now. This one it is for central fringe. Okay, fine. Okay, fine.
Yes, sir.
Now see. So upon this one, we'll have total number of fringes will be 641. Total number of bright fringes will be. Okay.
Yes, sir.
Hmm. This is the question. So option D. Right.
Yes, sir. Completed.
Completed.
Completed, sir.
Fine. Okay, fine. See the next question. In a Young's double slit experiment, in a Young's double slit experiment, okay,
Yes, sir.
okay, with a slit separation 0.1 millimeter means what? Okay, one
Distance
observes,
between both slits.
uh, indicated by which letter?
Capital.
Small d, na? Distance between the slits. Distance between the
Yes.
slits now. Okay, and they gave theta by using a light of wavelength lambda 1, and when the light of wavelength lambda 2 is used, a bright fringe is set up. Okay, bright fringe. Both the cases, bright fringe only we got. Okay, is seen at the same angle in the same setup. Given that lambda 1 and lambda 2 are in visible range. Okay, their values are,
Yes, sir.
okay, their values are, okay, fine. Firstly, they gave that it is, okay, they gave that it is the slit separation distance they give, or we can write it as slit width, right? Okay, that is given as 0.1 mm, 0.1 mm,
Yes, sir.
0.1 mm, and angle they gave it as 1 by 40 radian, right? Okay, from
Yes, sir.
previously we got it as sine theta is equal to yn by capital D.
Yes, sir.
For bright fringe, or you can write as that is equal to delta by d. So for bright fringe, I can write d sine theta is equal to n lambda
Yes, sir.
right now. So that means here you can see when theta is small, 1 by 40 means it is very small now, 0.025. So
Yes,
I
sir.
will write as d into theta equal to n lambda. Okay. So lambda 1 equal
Yes,
to
sir.
d and theta are constants. Only variable it is n only. And lambda 2 equal to d theta by n2. D multiplied by theta. Okay.
Yes, sir.
It is not d theta. So lambda 1 equal to 0.1 into 10 power minus 3 into 1 by 40 by n1. This I can write as 10 power minus 4 by 40 and 1. Okay, fine.
Yes, sir.
So 1 by 4 means I can write 0.25 into 10 power minus 5. 10 power minus 5. Okay, which will get it as multiplied by 10 power minus 5 by n1. Okay, okay.
Yes, sir.
What I will do, I'll multiply and divide by 10 power minus 4 so that it will be nanometer.
Yes, sir.
2500 by n1 nanometer. They gave that wavelength range. It is lies in between 380 to 740. 380
Yes,
to
sir.
740. Suppose n1 is equal to 2. It is not in this range. Okay.
Yes,
So
sir.
n1 must be n1 equal to 4.
Yes, sir.
When n1 is equal to 4, lambda 1 equal to 625 nanometer. And similarly,
Yes, sir.
lambda 2. Okay. Here also we'll get d and theta are same now. 2500 into 10 power minus 9 meters by n2. Okay. Suppose n2 is equal to 5. That means lambda 2 equal to 500 nanometers lies in this range. So that is
Sir.
option D. 625 nanometer, comma 500 nanometer. Right?
Yes, sir.
Okay. Right.
Entrance.
Completed.
Yes, sir.
Next question. Consider a Young's double slit experiment shown in diagram. Okay. What should be the slit separation D in terms of wavelength such that the first minimum occurs directly in front of the slit. They are asking for what separation distance of the slit, for what value of D. Okay. Such that first minima occurs. Okay. First minima occurs.
Yes, sir.
Whenever the first minima occurs, the path difference will be 2n minus 1 into lambda by 2.
Yes,
2n
sir.
minus 1 into lambda by 2.
Yes, sir.
Since they gave first minima, so n equal to 1, that is delta equal to lambda by 2. Okay, na?
Yes, sir.
Fine. So since we know that from our concept, we know that path difference means S2P minus S1P. They gave that capital D as 2D right now.
Yes, sir.
So I can write first S1P whole square equal to 2D whole square plus, okay, 2D whole square plus D square. Okay, fine.
Yes, sir.
S2P square is equal to S2P square is equal to, sorry, this is S2P square and here it is S1P. S1P is nothing but 2D whole square, right?
Yes, sir.
This is S2P, this is S1. So S2P minus S1P square square, that is 5D square
Yes, sir.
minus 2D. 1 minute. Instead of doing this one, we'll do one. S2P is equal to root 5D and S1P is equal to 2D. So S2P minus S1P is equal to root 5 minus 2 into D. Right?
Yes, sir.
So delta, this is nothing but S2P minus S1P is nothing but S2 path difference delta. So it is root 5 minus 2 into D is equal to lambda by 2. So D equal to lambda by 2 times root 5 minus 2. That is option C. That is option C. Okay. This model is most important. Okay. In the advanced, they gave the this path difference and asked to find the this one number of fringes. Actually, they asked in the opposite manner. Okay, na?
Right, sir. Yes, sir.
Next one. In Young's double slit experiment, the path difference at a certain point on the screen between two interfering waves is 1 by 8th of wavelength. Is 1 by 8th of the wavelength. The ratio of intensity at this point to that at the center of a bright fringe is close to the center of the bright fringe. Now, see, that is, firstly, path difference is given. That is, delta is equal to lambda by 8, 1/8 of the wavelength, right? So, correspondingly, I'll find phi, phase difference. That is 2 pi by lambda times lambda by 8. That is delta. So, we'll get phase difference as pi by 4. When phase difference is pi by 4, when phase difference is pi by 4, I am finding the resultant intensity. That is I1 plus I2 plus 2 I1 I2 cos phi. Okay.
Yes, sir.
Now, see here, the ratio of intensity at this point to that at the center. That means here, both the from both the slits will have the same intensity. That is I naught plus I naught plus 2 I naught square, 2 I naught square cos pi by 4. Cos pi by 4. Okay. Okay. 2 I naught square cos pi by 4. That is nothing but 2 I naught plus 2 I naught square cos pi by 4 means 1 by root 2. Right?
Yes, sir.
Okay. Na? So it will be 2 I naught plus root 2 I naught square.
Yes, sir.
Okay. Na?
Yes, sir.
Mm, I naught plus I naught plus 2 into this is the formula. Na? Forgot. This is under root. So it will be 2 plus root 2 I naught. Fine. Now at the center means at center means phase difference phi is equal to 0. So then the resultant I dash equal to I naught plus I naught plus 2 times under root I naught square cos phi. So that is we'll get as 4 I naught, 4 I naught. Okay. So they are asking the ratio, that is I resultant by I dash resultant. I resultant it is 3 point or 2 plus root 2 times I naught by 4 I naught. 2 plus root 2 means 1.414. So
Yes,
approximately
sir.
3.414 by 4. That is approximately 0.8, 21, 5, 0.85. So answer will be D.
Completed.
Completed. This one.
Yes, sir.
Yes, next one. In a double slit experiment, green light falls on a, we are having a green light falls on a double slit having a separation of, okay, and a width of, this one. The number of bright fringes between first and second diffraction minima. Second diffraction minima. So, firstly, it is that wavelength is given as 5303 angstrom. That is nothing but 5303 into 10 power minus 10 meters. Okay.
Yes, sir.
And distance between the slits. See, double slit having a separation, that is slit separation, it is 19.44 micrometers. That is nothing but 19.44 into 10 power minus 6 meters. And a width,
Yes,
that is slit width. I can write it as 4.05 micrometer. That is 4.05 into 10 power minus 6 meters. Now they are asking number of bright fringes between first and second diffraction minimum. Okay, first and second diffraction minimum. So diffraction minimum, diffraction minimum. Okay, that is path difference in diffraction. It is a sine theta, a sine theta plus lambda by 2 additional path difference, right? Since it is minimum, we can take it as 2n plus 1 into lambda by 2. So that is a sine theta must be equal to n lambda. Okay, na?
sir.
Fine. So for low angles, sine theta, I can write as theta. Okay,
Yes, sir.
okay, fine. So we can write it as a into theta is equal to n lambda. So
Yes, sir.
theta equal to, first they ask first minimum, na? N equal to 1.
Yes, sir.
Okay, n equal to 1. That is lambda by a.
Yes, sir.
This is for first minimum. And for second minimum, that is a into theta dash. A into theta dash. That must be equal to 2 lambda. Okay. Okay, fine. Now here whenever it is this one 2 lambda, this A slit width will be different.
Yes.
Slit width, this one. Okay. So that means slit width will becomes as 2D. That is theta dash equal
Yes.
to 2 lambda by 2D. That is nothing but lambda by D. So number of fringes between the first minimum and second minimum. It is theta by theta dash. That is lambda by A by lambda by D. That is nothing but D by A. D they gave it as 19.44 and A as 4.0. Both are in micrometers only by 4.05 into 10 power minus 6. Right? So
Yes, sir.
approximately this one, how much will get? 1944 by 405. How much will get? Approximately
Here to 5.
405 are how much? 2025 now. So approximately it is 4.8.
Yes, sir.
Okay, right? 4.8 will get. Since it is number, we'll use the step function that is equal to 5.
Yes, sir.
Okay, so the option will be option A. Okay, right.
Yes, sir. Yes, sir.
Completed. Mm,
Completed, sir.
completed. Fine.
Yes, sir.
Next one. See the next question. Unpolarized light of intensity I passes through an ideal polarizer A. Another identical polarizer B is placed behind A. Okay. The intensity of light beyond B is I by 2. Another identical polarizer is placed between A and B. The intensity beyond B is now found to be 1 by 8. The angle between A and C. Okay, fine. So, firstly, let us consider this is the axis. Here I am having a polarizer. Suppose this is A. Okay, okay, fine. Another identical polarizer is placed behind A. Suppose here we are having the another polarizer B. Okay, behind A. Okay, now it is the intensity of light beyond B is found to be beyond B is found to be 1 by 2. Okay. Another identical polarizer is placed between A and B. Between A and B. That means here, between A and B, the intensity beyond B is found to be 1 by 8. Suppose here it is there. This is C. The, here, what I will consider that The angle between A and C is alpha, and the angle between C and B, I will consider it as beta. Okay, fine. Initially, we are having an intensity I. So I can write I1 is equal to intensity. Initially, this I it is unpolarized. We'll get I naught by 2 or I by 2. That's what they give. See here.
Yes, sir.
Okay. So intensity of the polarizer, see, emitted polarizer will get intensity of A times cos square alpha. That is nothing but I by 2 cos square alpha. Right?
Yes,
Okay.
sir.
Fine. Now from the B, the intensity is 1 by 8. So we can write intensity of the B equal to IC times cos square beta. That is given as
Yes, sir.
IC. We got it as, I think, I by 2 cos square alpha. I by 2 cos square alpha. And this one is cos square beta. This value they gave as I by 8. Okay, fine. So I can say that cos square alpha and cos square beta is equal to 1 by 4. Okay, so cos alpha and cos beta is equal to 1 by 2, right? That means if we solve this equation, we'll get alpha equal to 45 and beta is equal to 45,
Yes, sir.
right? That is option C, 45.
Yes, sir.
Mm. First, draw the diagram and write down equation.
Yes, sir.
Okay.
Yes, sir.
Completed.
Yes, sir. Yes, sir.
Completed.
Yes, sir.
Next question. The angular width of a central maximum in a single slit diffraction pattern is 60 degrees. The width of the slit, that is small r d. Width of the
With
slit means A,
smaller.
small a. The slit is illuminated by monochromatic plane waves. If another slit of same width is made near it, Young's fringes can be observed on a screen placed at a distance 50 centimeters, that is capital D, from the slits. Capital D is given. If the observed fringe width is 1 centimeter, what is the slit
Yes, sir.
separation distance? That is, we need to find small d. Okay, fine.
Yes, sir.
So, firstly, they gave, first we are having the diffraction pattern, and then we are having interference pattern. In the diffraction pattern, theta equal to 60 and A equal to 1 micrometer.
Yes, sir.
Theta equals 60 degrees A equal to 1 micrometer. Okay. And they gave that it is the angular width of central maximum, that is n equal to 1. I can write as, okay, diffraction. Okay.
Yes, sir.
Minimum or maximum, their central maximum is 60 degrees. The slit is illuminated. Okay. Okay. Fine. The slit is illuminated by monochromatic plane waves. Okay. It can be observed on the screen. So, since we know that A sine theta, since it is maximum now,
Yes, sir.
okay, for maximum, it is 2n minus 1 into lambda by 2, or we can say bright fringe. We can say
Yes, sir.
bright fringe. So that is n equal to 1 belongs to central fringe. Central
Yes, sir.
fringe. That means A sine theta is equal to lambda by 2. Okay,
Yes,
now
sir.
fine. So I can find lambda. Now, whenever it is central, this one, we can write as slit width as A by 2. A by 2. That is A sine theta is equal to lambda. So lambda equal to A means this one, and you can see we are having this is the source and this is the slit. Okay, this
Yes, sir.
angle. Okay, they gave here it as 60 degrees. So here it is 90. So I can say this as 30
Yes,
times
sir.
sine 30. That is nothing but lambda equal to 1 by 2 into 10 power minus 6 meter. Okay. Now,
Sir.
in case of interference, we can write yn is equal to capital D by small d times delta. In the interference, did they ask for the Young's fringes at a distance? Okay. Here also it is maximum only. Okay. Maximum means central maximum means capital D by small d times lambda. Actually, I should write 1 into lambda. So small d equal to capital D into lambda by fringe width. Capital D, distance between the slit and screen, they gave it as 50 centimeter and fringe width as 1 centimeter. Okay, that is 50 into 10 power minus 2 multiplied by 10 power 6, 10 power minus 6 by 2 into 1 centimeter, right? Okay,
Yes, sir.
so D equal to 25 into 10 power minus 6 meter. That
Yes,
is
sir.
nothing but 25 micrometer.
Yes, sir.
That is option A.
Yes, sir.
Right.
Complete answer.
Completed.
Yes, sir.
Next one. See the next question.
Yes, sir.
That is the box of a pinhole camera of length L has a hole of radius A. It is assumed that when the hole is illuminated by a parallel beam of light of wavelength lambda, the spread of spot is the sum of its geometrical spread, and the spread is due to diffraction. The spot would then have its minimum size. Okay, we need to
Yes, sir.
find this radius and as well as the this size of the spot. Okay, fine.
Yes, sir.
Okay. Initially, we have the source and we are having the slit like this. Here we are having a screen, undeviated
Yes, sir.
or central fringe. This one it is center, right? Okay,
Yes, sir.
fine. Suppose let us consider this one. This is theta. Okay, now they gave that distance. This distance is L. Okay, okay, fine.
Yes,
And the
sir.
slit width approximately this one. This is slit width A. Okay, since we know that, since we know that uh, for the minimum condition is this one. So A sin theta must be equal to lambda by 2, right? For
Yes, sir.
maximum, this is for maximum. And for minimum, it is A sin theta equal to n lambda, right?
Yes, sir.
A sin theta equal to n lambda. Okay.
Yes, sir.
Hmm. Okay, fine. Now you can see that it is A sin theta equal to minimum. So size of the spot, you can say that that is indicated by B. That is indicated by B. Now I want to find from here to here what is the distance. Okay, yn equal to capital D by small d into delta n. That is capital D means L. Okay, capital D means L and small d means A, and this one first maximum is L. So this distance will be L lambda by A, first maximum. Okay,
Yes, sir.
okay. We are having above the central fringe and below the central fringe. So we can write as 2A plus 2 times L lambda by A. Okay.
Yes, sir.
So for B to be minimum, dB by dA must be 0. So dB by dA equal to 2 minus 2L lambda into 1 by A square is equal to 0, right?
Yes, sir.
So 2 minus 2L lambda by A square equal to 0. So
Yes, sir.
A square must be equal to L lambda. So A equal to
Yes, sir.
under root L lambda. Whenever I substitute, since B equal to 2A plus 2L lambda by A, that is B minimum is equal to 2 into under root L lambda by root L lambda. That is 2 times under root L lambda plus 2 times under root L lambda. So that is 4 times under root L lambda. This is what B minimum. Okay. Na?
Yes, sir.
So radius of the spot B by 2. Okay. Well, whatever we got here, it is diameter. Na? So
Yes, sir.
4 into root L lambda by 2, that is 2 times under root L lambda, or we can write under root 4 L lambda. So A equal to under root L lambda, A equal to under root L lambda, and B minimum, that is option C. Okay, right on.
Yes, sir.
Okay, na? Completed.
Yes, sir.
Right.
Completed.
Completed. Okay. See the next question. Assuming human people to have a radius of 0.25 centimeter and comfortable viewing distance, that is least distance of distinguishing. minimum separation between two objects that human eye can resolve. Human eye can resolve 500 nanometers. That means initially they gave the radius, that is 0.25 centimeter. Okay. From this, okay, we can find the diameter. Diameter equal to twice the radius, that is 0.5 centimeter or 0.5 into 10 power minus 2 meter. Okay. And least distance of distinct vision, it is 25 centimeter. Okay. Now lambda is equal to 500 nanometer. Okay. Now, fine.
Yes, sir.
We know that limit of resolution theta is equal to 1.22 lambda by capital D. That is
Yes, sir.
1.22 into 500 nanometers. 500 into 10 power minus 2 by capital D. That is diameter. That is zero point 0.5 times 10 power minus 2. So 1.22 into 5 into 10 power minus 7 by 5 into 10 power minus 3. That is 1.22 into 10 power minus 4. Okay. Okay. We need to find, suppose this is radius. Okay. We need to find the, how much it can resolve. Okay. How much it can resolve. So we can say that sine, sine theta is equal to yn by capital D, right?
Yes, sir.
So y by capital D, it is 0.5 into 10 power minus 2 is equal to theta, that is 1.22 into 10 power minus 4. I think. How much you got? So y is equal to 1.22 multiplied by 0.5. 1 minute. Okay, fine. Right. Into 10 power minus 6. Actually, here they gave the radius. Na? Here they gave radius. Na? Mm, we should write it as 1.5 by 2. That is 0.61 into 0.5 into 10 power minus 6 meters. Approximately zero point 0.3 micrometers.
Yes, sir.
Mm. 1 minute. Yn by they gave the radius, that is equal to theta. So yn is equal to theta into r. Theta it is 1.22 into 10 power minus 4. The radius they gave us 0.25 centimeter. That is 1.22 into 1 by 4 into 10 power minus 6 meter. Okay. Na?
Yes, sir.
Uh, this one it is D, 25 centimeter. that is multiplied by 25. 1.22 into 25, 50, 55, 30, 30.5. Okay, into 10 power minus 6 meter. So approximately it is 30 micrometer. Yn by capital D now. This is capital D or LDDB. Get it. Okay. Right on.
Sir.
Okay, na completed.
Completed. Completed, sir.
Completed.
Yes, sir.
See here, they gave that it is one of the slit is wider than the other. Okay, one of the slit is wider than the other. So that amplitude of the light from one slit is double that of the other slit. Okay, double that of the other slit. So that means I can write A1 is equal to 2 times that of A2. And IM is the
Yes, sir.
maximum intensity. Okay, the resultant intensity I when they interfere at a phase difference of 5. So firstly, maximum intensity means I can write root I1 plus root I2 whole square.
Yes, sir.
Okay. Okay, fine. Now we know the relation between intensity and amplitude is I is equal to this one. So
K
root
square.
I is equal to root K into A. So
Yes, sir.
root I1 equal to root K into A1. Okay. So
Yes, sir.
that is root K times A1 plus root K times A2 whole square.
Yes, sir.
Okay. A1 means 2A2 now. So root K
Yes, sir.
times 2A2 plus root K times A2 whole square. So I max is equal to 9. This one root K A2. 9K A2 square. That is nothing but 9 times I2.
Yes,
Okay,
sir.
now? Okay. Let us
Yes,
consider
sir.
this as I naught. That is equal to 9 I naught. Now, resultant intensity I when there is a phase difference 5. I is equal to I1 plus I2 plus 2 times under root I1 I2 cos 5. Okay, 5.
Yes, sir.
when amplitude, you can see first wave amplitude is twice that of the second. So intensity will be 4 times of the
Yes,
second
sir.
one. 4I2 plus I2 plus 2 times under root 4I2 times I2 cos phi. Since I consider I2 as I naught now,
Yes, sir.
this one it is, we can write it as 5I naught plus 2 into 2I naught cos phi. Since I2 is equal to I naught. So I naught times 5 plus 4 cos phi. Okay. And I max, I
Yes, sir.
got it as 9 I naught. Right. So
So
what they
I
asked
naught is
one,
equals to I max by 9.